And so I think a lot of this is, the game that we're playing here. If we get back to like what we talked about in fundamental software architecture, these katas, that's exactly what these system design interviews are. It's this hypothetical scenario, and can you figure out the like jujitsu way of cutting through the ambiguity, getting to the core of the problem you're trying to solve, and then come out the other side with something reasonable out of a proposal and collaboration.
Hey there, welcome to Book Overflows, the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, we are excited for the episode today. You got to change the scenery, Nathan, for any of our video listeners.
Yeah,
where are you at?
I'm at a conference in Denver, so that's what.
That's not too far from where you live, right?
I get to hold my microphone today instead of using a fancy stand for it. No, it's
Nice.
not. It's only like an hour from where I live, but I was like, the commute back and forth, traffic's terrible, and so the company provided a hotel, and I was like, I will take it.
I'm jealous of I go to Toronto for business sometimes. We got a couple engineers that live there, and like they just drive to Toronto. It's really nice.
Yeah.
Well, we got a new book for you this week. As always, like, comment, subscribe wherever you're at. Share the podcast, helps us grow. But the book this week, we're very excited. It's a System Design Interview by Alex Zhu. You might know him more as the creator of the wildly popular newsletter Byte Byte Go. We're going to talk a bit more about Byte Byte Go. We have lots of nice things to say about it. So let's give the introduction here. But a little bit of background on Alex Zhu. He's an experienced software engineer and entrepreneur, and he's previously worked at Twitter, Apple, and Zynga. He received his master.
Yeah.
Oh, Zynga? Is that it?
Yeah.
That's one of those words you only ever read.
I knew a guy who worked at Zynga. That's why I knew how it was pronounced.
He received his master's from Carnegie Mellon University. He has a passion for designing and implementing complex systems. And that's great because that's what this book is all about. The book introduction we get says, system design interviews are the most difficult to tackle of all technical interview questions. The book is volume 1 of the System Design Interview, an insider's guide series that provides a reliable strategy and knowledgeable base for approaching a broad range of system design questions. This book provides a step-by-step framework for how to tackle a system design question. It includes many real-world examples to illustrate the systematic approach with detailed steps that you can follow. Very, very interesting book, a very dense book. We've been enjoying it. We read the first half through chapter 9. We'll talk maybe later in the podcast, but next week we're going to take a quick break from it. I have an on-site and just my schedule's kind of crazy, so we're going to do an essay to save some time, but then we'll cover the next half after that. All that to say, just the first half this week. Nathan, what are your thoughts after reading the first half of System Design Interview?
Yeah, I thought it's a great format if you're preparing for a system design interviews, and I think when you are in that point in your career, if you're looking to switch, it's a slog. You got to do a lot of prep work.
Oh yeah.
This is the kind of density that you'll get a lot of value out of. I didn't think it was easiest to read cover to cover. Of course, we've talked about that before. It's our fault because it's the format of this. But I felt myself nodding my head and going, oh yeah, I hadn't thought about bringing up that point. I felt like I would do pretty well in a lot of these system interview questions. But I was like, oh yeah, there's like the 90% and then like the 95% good answer. And that last 5% can be the deal breaker, when you're interviewing. So yeah, I thought it was a great book. What did you think about the format?
I've been recognizing that too, where I'll be with him 90% of the way, oh yeah, I know how to do this. And then there's a little bit of stuff he brings in at the end. I'm like, oh, you would look so smart if you brought that up. Yeah. So it's been really cool for that. Very good mix of depth and breadth. We've talked about that on the podcast. We are kind of just by nature a breadth podcast. That's what happens when you read a book every 2 weeks or so. I wish I had more time to deeply study certain chapters. We just have to keep a pretty fast pace here. And there were ones where I'm like, oh, I got to come back to this. It is what it is. It's the guide for prepping yourself for system design interviews. And I find it essential. Until this point, I've always recommended Cracking the Coding Interview for system design interview questions. And it's a great book too. And it's great for a lot of reasons. This is like that on steroids. I also like this book because it congratulates you after each chapter.
Yes, I loved that. It has a nice set of references like that. Again, I appreciate
lots of references. He's like, "Hey, you made it this far. Good job." I'm like, "I did make it this far, Alex. Thanks." So yeah, this has been a fun one. We mentioned on the podcast before, we're trying to find the right balance between technical and career focused, and even non-technical, right? We've kind of run the gamut so far this year. We have Software Engineer Guidebook that's very career focused. We have Team Topologies, which is like obviously team focused. And then this is very, very technical, along with Hypermedia Systems. So yeah, it's fun to get another one of these very technical books. And we're excited about all of it. We're not going to spend too much of this podcast talking about the nitty-gritty details of all the different system designs. You'd be better served by reading it, but we're going to talk about a lot of the system design stuff and just system design interviews in general, and Byte Byte Go. So we've got a lot to talk about this episode. So stay tuned. We'll be back with all that and more. And we are back. Thank you so much for listening. So let's talk just a bit about Alex Zhu and his newsletter, Byte Byte Go. Now, Nathan, you are more familiar with this than I am. I know of Alex, I know of Byte Byte Go, but I'm not a subscriber. I should be.
Yeah, no, this is great. So where, there's a lot of great like growth engineering type Substacks and newsletters that are out there, especially for career development. This one's very focused on like how does Netflix scale to, 1 trillion transactions, and it gets really into the architectural designs. And I'll say that Byte Byte Go is an amazing resource. You've maybe even seen he's gotten kind of famous with these sort of like animated GIF data flow things that if you look at LinkedIn, his stuff goes viral all the time. What's nice is that his viral content that's really consumable in the newsletter is not just a regurgitation in the systems design book.
Oh, okay.
It's so they're like complementary, and I think it's nice that if you need to go into these deeper understandings of like how do I actually ace this systems interview, this book's fantastic. But Byte Byte Go, I highly recommend taking a look at it, because again, I love to know how things work, or how does a tech company like solve certain types of problems, and they pull no punches. It is, I would say it's the systems design equivalent of Lenny's newsletter, which Lenny's newsletter is a product oriented newsletter. The guy who came from Airbnb, fantastic resource as well, especially if you're like doing product design or product engineering. Byte Byte goes up there with that, and I think they're huge. Like last time I checked, they have like over 1 million Substack subscribers. That's crazy. That's just like
that is insane.
Yeah, so that's really neat.
It's I think as we're doing all of this, you wonder kind of, is it all worth it, right? Like all this continued education.
Okay, I was like, where are you taking this? You're getting real existential for a second, Carter.
Think about life lately, and no, well, I think about that with the podcast. I think it's no secret with the podcast, right? That this is it's a non insubstantial reading commitment, right? And there's definitely been nights before we record where I've had to read 90 or 100 pages, because I fell behind that week. And you sometimes wonder like, oh man, we're reading so much. Are we even getting anything out of this? And I think the reason I bring this up is because I think that applies to a lot of continued computer science education, and Byte Byte Go is a great example here. And you kind of wonder, how much of a competitive edge am I really getting? I just want to give my take on it, which is like, I think we are gaining a substantial competitive edge. And if you don't like to think of it as a competitive edge, I think we're just learning a lot. I've actually been kind of working on like a greenfield project lately on my own. And I have been shocked at how much kind of latent knowledge from all the books we've read is immediately becoming useful in designing and building this thing. So I think, if you're not willing to be sickos like us and read a book, or 200 pages a week or whatever, seek out good resources like Byte Byte Go. I mean, that it's going to be a big boost in your career and how useful you are as an engineer.
And I would say this is an excellent resource that's a complement to the Pragmatic Engineer content as well, where you do need a balance of career strategy and engineering excellence learning strategy. And you can't just be the systems expert. You really do need to know how to like also incrementally build this in a way that can deliver value to your team, right? You have to do both. Yeah, I think the systems interview is a sort of dance, right? That you have to go through with the interview process. That you might do a coding interview. Increasingly, I've had amongst my friends, especially as you move up in seniority in the interview process, they expect a solid showing in a system design interview.
Absolutely.
You have to understand why you're building something, what you're building, how you're building, how do you get to the requirements of it. And this book does a really good job, I think. There's a whole chapter dedicated to like just how to gain clarity. You have a 1 hour window typically, 45 minutes to an hour. They're going to give you some technical design that you're going to have to come up with. And you basically have to go from, I have no idea how to implement this, to nailing down some of the requirements and what are not requirements, because you can assume all kinds of complexity in your brain. And the game really is, how much complexity can I strip out and then show that I understand how to build a system like this in a 1 hour window, right? That's not real life. You're not going to be expected to do that. But if you know how to play this game and you know these patterns, it's not different than knowing the time complexity of an algorithm that you're doing for some technical interview, right? It's just now you're dealing with like distributed systems or hashing algorithms or databases or caching or any one of these topics that might come up. And so yeah, if you take a positive view to like, okay, this is a game I'm playing. Well, understand the rules of the game you're playing. You may not love that you have to play this game, but know the rules and you can do the best version of what your knowledge has to offer. Right? And yeah.
Most of our listeners probably understand what a system design interview is, but I'm always surprised breaking down the demographics. We have a decent chunk of people who are like 18 to 24 years old. So lots of college students. Just in case you're not familiar, system design interview is different from a coding interview. A coding interview, right? You're presented with one coding question, right? The famous one is invert a binary tree or reverse a string or whatever. System design interview, much broader, right? And that's where you'll get questions like design Instagram. The examples we have here in this book are like design a rate limiter, design consistent hashing, design a key value store, design a unique ID generator in distributed systems, design a URL shortener, all sorts of things like that. I actually really like system design interviews. I like giving them and I like doing them. I mean, no one likes doing interviews, but out of all the interview types, I think it's my favorite.
Me too.
You get a lot of points in system design interviews in the how you approach them and not just the what you're building. This book is all about the what you're building, right? It has lots of really great patterns for building these specific types of systems. But one thing I think is cool about system design interviews is you get a lot of credit just if you can explain your ideas well. You get a lot of credit if you can ask the right questions. You get a lot of credit if you're engaging your interviewer throughout the process. You can't be a total bumpkin and like not know anything, but you can really plus up your performance by having some good bedside manner. So I like it. As someone who who hosts a podcast and can ramble for an hour every week, no problem. This interview plays to my strengths.
Yeah, and I thought the book did a good job of. I mean, again, these are sane defaults. These are not the way you have to approach this. But one of the things I liked about the structure of the book is they kind of go instantly into a design interview question, which is like scale from 0 to 1 million users, without giving you a real structure of how to answer this question. But they kind of walk you through like things you need to reason through, and so from a scale from 0 to 1 million users, you basically have to design a very simple system. And you go, okay, well, if I hit this scaling threshold, I'll add a load balancer, and get to this one, I might need read replicas on my database. They also have this idea of a framework for approaching the system design, and they get to that by chapter 3. And actually, they use this every time they build on something. They use it for the rest of the book, right? And I thought the 4-step process I thought was useful. And again, this is where the value you get out of this, where it says, understand the problem and establish the design scope. Propose Step 2 would be propose a high level design and get buy-in. I can't tell you how important that step 2 is, where you're basically fishing, right? You're saying, hey, I could take this approach. Is this the direction that you kind of are thinking? And they may go, oh yeah, you could take that approach and go further. Or they might go, oh no, you don't have to worry about consistent hashing in a distributed database or something. You can assume that that's done for you, right? Well, that takes a huge design component off your plate, right? You don't have to go off in some rabbit hole of talking about, hashing algorithms that will rebalance themselves after, you take something out of a pool, or, some really technical thing that you could spend the whole interview on. They go, oh, no, we have that solved. Focus on this part, right? If you can do that earlier in the interview, you're not going to go, because what I've done this before, right? I've done a systems interview earlier in my career where I realized I was just barking up the wrong tree at the end of it, right? I probably gave a very technically correct thing that I fixated on, as opposed to solving the deeper problem. That's something that comes with maturity, of saying, what business problem am I really solving here? Like, what are they really trying to get to? And then you have to do your deep design, right? Like, most of the rest of it is you're going to be expected to dive in deep to what the two of you have kind of agreed on in the interview. And if you've picked the right direction, the interviews are awesome. They're fun. You get to collaborate. You get to kind of show your knowledge. And then you have to wrap it up, right? At the end of it, you go, okay, well, with this and this and this, I think, and they talk about back of the envelope. They're like, oh, you do some back of the envelope calculations. I think this would meet the criteria that we talked about at the beginning with this design that we just did, right? It's also like the same format of how to write a good essay, right? But I thought this book gave us a good framework of how to think through these things, which is nice. When you're nervous in an interview, you need a framework.
And that skill you talk about get buy-in early.
Yeah.
That's a skill you need at work.
Oh my gosh.
Right?
Yes, absolutely.
That's something I've been working on. We are preparing to take our service from internally what's known from tier 3 to tier 2, which just means that more people rely on it. And so with that comes a higher expectation of of availability and reliability. And one thing you need to do to show that you're doing that is they're called game days. I think that's a standard industry term, but right, you need to be simulating outages with the team, right, and then working to fix them. I'm in charge of kind of planning and executing these game days, and I was figuring out, I'm like, okay, well, in order to do this, we either need to be able to run game days in production, which is possible, but requires a lot of tooling and ways to not break everything, or we need to have enough of a production-like environment that running a game day in there will actually accurately simulate what it's like to do, to debug something in production. And there's a lot of hurdles there, neither insurmountable. Between those two options, but I was just I was talking with one of the other staff engineers and just saying what do you think between these two options? He proposed a third one. He's like, what if we just Dungeons and Dragons it, right? Just have a simulation of what's going wrong, and then we just have people, they say oh, I got to look at the graphs to figure out what's going on, and you're looking at graphs that are normal, they're not showing anything, but as they look through them, maybe you say, okay, you found the right graph, and then you show them an image of what it is supposed to look like or whatever, right? And we liked this option just because it's going to be 1/10 of the amount of work as pursuing either the other two options. But this is something I floated with the other tech leads and with my manager, and was like, hey, what do you guys think about doing it this way instead? And got buy-in from everyone. Oh, that's great. You can imagine a scenario where instead, even before talking with that original staff engineer, maybe I embarked on a really big project to duplicate all of our production data and set up another production server or whatever, and do all these things, and then okay, great, we can run our game day. And people have been like, why'd you spend 3 weeks on that? We could have just done it like Dungeons and Dragons style. Or you can imagine another scenario where I proposed, where I'm like, okay, I got a game day, we're doing it Dungeons and Dragons style. And my manager is like, what are you talking about? We can't do Dungeons and Dragons game day.
Right.
So getting that buy-in, it's important.
That's cool. I like that. And exactly, getting. We recently had this. I have a greenfield project at work as well. I have a small team that I'm managing, and we initially interpreted some requirements in a way that we were kind of getting down this rabbit hole of like, oh man, these are going to be really hard. Like I just identified like there's lots of unknown unknowns. Like we just don't know exactly what we're going to. And we went back to get clarity. It's actually a project that has the attention of our CEO. And we were kind of ideating through things and realized we could do this in a much simpler way for like a V0, like the initial prototype. And it de-risked our project tremendously. It took something that I was worried it was going to take maybe 3 months or something to work on to something that I think we could turn around in about a month and a half, right?
Nice.
With some incremental stuff we're shipping in between. But it was really important because I like something, again, I was like worried about. I'm like, oh, this is going to be really complex. And how do we make it simple for the user? We realized we just didn't need it, especially early on. Like we were like, no, we'll just do a very simple version of this, remove some of the optionality for the user, which opens up optionality for us. And we've talked about optionality with Kent Beck. We can put little placeholders in our code where we can add complexity later, but the initial implementation can be very simple, right? We don't really expose this in a way that makes it so that, because we don't know how the user is going to use the tool all the way. And if we add a bunch of features, the users will inevitably start using features that we've given them. And maybe we didn't want to give them those features, right? Maybe we realized it was kind of a halfway thought of idea. And it's way harder to take that away from somebody than to just like be like, here's a really stripped down version. Oh, and here's a new feature. Like add these out incrementally. And here's a negotiation, right? We couldn't just strip those features out. If there was an expectation from our product team that something was there day one, we would have to accommodate that with timelines and everything else. But if you can get permission to say, okay, I'll do a naive approach on purpose, right? We'll do this so that we can incrementally add these things. And then product people love it because they get to go, oh, here's on our feature roadmap, and they can like roll things out and show that they're making improvements. So it is interesting to figure out how to go about an incremental or an evolutionary architecture design in the right way. And that's a fun dimension too.
Yeah, I'll say, I think there's a good argument that the interviewing process for software engineering jobs is roughly broken. I've talked about it on the podcast before, but I defend it at the high levels. Like if you are literally Apple or Google or Netflix or Amazon or whatever, and you have thousands of applications and, you can afford to reject good engineers because like for you, the much riskier outcome is accidentally hiring a bad engineer. Then you can do the whole leak code song and dance because you lose a lot of good engineers by doing leak code, but you rarely hire bad engineers from it. System design interviews are, I think, the least broken part of the process. You're right, Nathan, that there's obviously like you're not going to sit down and design Netflix in 1 hour. But these are, I think it's the most applicable mapping of skills, from the interview to the job. And I find myself engaged in these sort of system design interview questions every day where I am never doing like leak code style coding on the job.
Right. Yeah, I agree. It also gives you an opportunity as an interviewer to see how collaborative this person is. And to me, that's a huge one. It's can this person own up on their weaknesses? Do they ask good questions? Are they able to navigate uncertainty? These are like all parts of the job. Those are all real world things. And if you can simulate this through a system design interview, you get a glimpse of it. It's not perfect, right? But you can be like, oh, this person jumps to conclusions and makes lots of assumptions and is already like tangled themselves up in this complicated thing. And this might actually be their approach to life. And that's going to be a hazard, right?
Mm-hmm.
And so I think a lot of this is, the game that we're playing here. If we get back to like what we talked about in fundamental software architecture, these katas, that's exactly what these system design interviews are. It's this hypothetical scenario. And can you figure out the like jujitsu way of cutting through the ambiguity, getting to the core of the problem you're trying to solve, and then come out the other side with something reasonable out of a proposal and collaboration? That's the art, and that's what people are trying to see with your output from this, right? They're like, oh, yeah, they asked some really good questions. They really got down to the core. Typically you have on the interviewer side, I'm just this is a good thing to bring up. If you're going to read a book about how to ace this, on the interviewer side, we typically have a rubric that says they should get to this point, or they should hopefully ask these types of questions, or ideally they ask clarifying questions to get to this design direction, right? At least the rubrics I've used in the past. And we try to use a rubric because we're trying to take something that's inherently creative and give a framework that people can succeed, and we can compare candidates against each other. Sometimes it's not easy to compare apples to apples, but have empathy for the interviewer as well, right? They remember, this is a game that they have on their side. If you're asking to design a rate limiter, well, you should understand the expectations of rate limiting. You should understand maybe 3 or 4 prominent designs and approaches that big tech companies have taken to doing rate limiting, the trade-offs that are there, right? These are the kind of things that if you want to be prepared for your interview, not just completely derailed, you need to know. And that's, you can't make that up. You don't know necessarily, like, if you don't know how Google does rate limiting or something, or an innovation that Flickr came up with, right? Like, and that's become the prominent pattern for something. You won't be as prepared. You might come up with a kind of creative answer, but if you don't know, like, oh, that there's this cool, hashing algorithm that servers can use that don't have to coordinate or something, right? That just shows your knowledge versus having to make something up on the fly. And if you yeah, go ahead.
No, you go ahead.
I was gonna say, and if you don't know, please don't lie. Like, if
yeah, that was
the other part. Oh gosh, I hate it when I have like a candidate I'm like resonating with, and I'm like, oh, they just BS'd me. Like,
yep.
Because I would much rather you go, you know what? I haven't worked with deep down rate limiters in the past, but I think that this might be how I would approach it. I would much rather that. Even if I might be in the moment a little disappointed that you don't know that much about rate limiters, I would then at least go, okay, well, you don't. Let's see how you navigate this. Like, okay, that's interesting. Like, tell me how would you approach this? And that's how you
set expectations low, folks. Yes. I do that with coding questions. I say, now, granted, I've never used Java before, but I'm just going to take a stab at it.
Okay.
I want to talk about some of the specifics in the book, but just before we move on to that, I just want to give us a chance. Any system design interviews you've done in the past that have stuck with you, either ones you've conducted or ones you've done yourself?
Ooh. Yeah, I was interviewing for like a staff level software engineering position. Actually, I think it was a staff level SRE position, site reliability engineering. And we were looking at, it was a high availability design on dealing with a bunch of, like, a high throughput API server that they gave a bunch of like observability constraints and some other operations constraints, because with SRE you're really worried about SLI, SLO, and SLAs, right? SLAs most people have heard of. That's like the sort of business agreement of like how much uptime something has. So maybe 99.99% uptime might be an SLA, but internally you have to tool out your service level objectives and your service level indicators. And so for an SRE, you have to have a very good knowledge of how SLI, SLOs, and SLAs relate to each other, because there's like, basically you have like the legal requirement of what you're promising a customer, but internally it's like, well, here's how we want to behave on a day-to-day basis, and here's how I'm actually going to measure it, right? And so the system design interview was like, well, how would you measure this? How would you build this in? And it was a lot of fun. It was actually like a collaborative whiteboarding session remotely, which it's the only time I'd ever actually had to use a whiteboard. Sometimes you'll ask to prepare stuff beforehand. Sometimes you kind of collaborate through. But I remember that one being like a lot of fun. I also did awesome on it, so like that one stayed at top of mind. What about you?
Yeah, I'm glad you had one you did awesome on, because the one that I remember is one I did badly on.
Those are both valuable lessons.
I know, right? So I'll say, one at my current company, we do a real deal system design interview. We also do a great kind of interview that we call the technical deep dive, which is almost like a system design interview that that you prepare for. Like you come with prepared materials. Like they'll say like, we just want you to walk us through a project you've worked on in the past, right? And so that's really cool because I showed up with like a whole architecture diagram, something I'd built, and then that I aced that one. My current company, I kind of aced our systems design and that technical deep dive, and yeah, did really well there. I think I was interviewing for, it was a software engineer position. I want to say at Stripe. And it was dumb. It's a good example of how you kind of want to stick with what you know.
Yeah.
Because I've been upfront in the past that like SQL is not my strong suit. I've done a lot of work with like NoSQL databases in the past. Just now trying to really throw myself in the deep end with SQL to understand it. One of the things that always scares me about SQL is like NoSQL, like you're using Amazon DynamoDB, lots of downsides with it, but it's always going to work pretty much. You can throw almost infinite amount of requests at it and it's just going to handle it no problem. Not true with a SQL database. And even if you're using something like AWS RDS, right, at the end of the day it's still a server node with your database on it. And I get really, really nervous about bringing the database down, right? It winds up being a single point of failure for the whole application. And so I'd gone to weirdly bizarre lengths in this interview to really minimize reads and writes on the database. And I just, I think it was very much like the frozen caveman pattern or anti-pattern that we read about in Fundamentals of Software Architecture. Like I'm sure they must have thought like, wow, this dude brought down a SQL database at one point. Now he is obsessed with it. It was the opposite. I've never brought down a SQL database because I never really worked with SQL that much. I just went to really, really great lengths to design this kind of convoluted architecture. Really what I should have done, and if I just known more, I should have said, I should have done some back of the envelope map. We're going to talk about that in a bit, but been like, okay, so how many reads per second? How many writes per second? What's the length of a record? How much is going to be stored in there? And even after all that back of the envelope map, if I had said like, listen, SQL, not my strong suit, I'm going to assume that we can have a sufficiently large, sufficiently powerful SQL database that the amount of reads and writes we're doing per second aren't going to be a problem. And that we have, and then in this particular application, I think I could have said like, and we'll never exceed more than 64 terabytes of data. And said, is that an okay assumption? I guess in this particular example, they would have said, yeah, that's fine to assume. And even they'd said, well, we would like to talk more about, well, what if there did get to be more data? Even if I'd put that kind of on the back burner and said, okay, that's fine. Let's assume that this one database can handle it for now. I'm going to build out the rest of the architecture.
Right.
And then come back to that. I was just bizarrely paranoid, and I think it didn't go well. I didn't get any feedback that was like, "Oh, that went really, really badly." But I think it, from my opinion, certainly not the strongest showing.
Yeah, no, I'm trying to think of where maybe those are the ones where like, yeah, you're trying to fish early on, and you're like, okay, is the hint that they want me to come up with a sharding mechanism, or is the hint that they that, you know what, I'm actually looking at this, and even though you told me to do this in SQL, I actually think NoSQL would be better. And are they actually seeing if I'll push back, right? Like, and you don't know, because they could be, oh, no, this has to be SQL, right? Like, that's fine. But sometimes when you're fishing, it's like, can you find the secret golden ticket that you're actually shooting for? And in the heat of the moment, sometimes you're just, it's like, going up and doing karaoke or something. It's like sometimes you pick an awesome song and you're like, I got this. This is my vocal range. It's a lot of fun. And then sometimes you pick a song and you're like, this didn't land, and I shouldn't have sung this. And why did I do this? And so I think the same thing happens here. You're like, with that system design interview, the reason I remembered it because it did really well. They were really excited. I ended up not taking that job. It was a vibe check thing. And I'll tell you, even after all this stuff, like, it was a good offer, fully remote. but I had mentioned I was in grad school because I was about to start grad school, and they were like concerned that I was going to use some of my spare time, like non-work hours, to work on this. They're like, "We might need to be available," and I was like, "What? Like, what are you talking about?" And then the other one was that I don't know, it just got a weird vibe. That company went bankrupt like 9 months
Oh,
later.
really?
Yeah, so I dodged a bullet, but just from a work culture standpoint, I was like, there was something weird. Even though technically I think I've been a great fit for the role. It was like a really kind of interesting problem to work on. It was in like I'd done some fintech stuff before. This is like a fintech company. Fintechs are fun because they went bankrupt because it was like they were in the crypto space, and one of their crypto investments went belly up, and they became insolvent.
Oh no.
Yeah, so it was like they were making a bunch of money. It's just, if you lose $1 billion or something, it's like you can't recover from that. So yeah, it was interesting.
Well, let's take a quick break, and then like we said, we're not going to talk about a lot of the finer details from all the different chapters. Please read the book yourself. There's tons of great stuff in here. But we're going to talk about some of the techniques he proposes and some of the concepts we found interesting throughout Alex Yu's book. So we'll be right back. And we are back. Thank you so much for tuning in. So let's talk about some of the strategies he proposes. These are things that pop up in all of the different chapters, because every chapter is associated with one specific type of system design. We talked about it in the first half of the podcast. Asking questions. You want to make sure you're on the same, you're on the same track as your interviewer. You got the same vibes going. You want to make sure you're not barking up the wrong tree. So at the beginning of each chapter, he has a really great, he just does like a little interview style, like the candidate and interviewer. Candidate asks a question, the interviewer responds. So I really like chapter 7, which was design a unique ID generator in distributed systems. I'll read just the prompt. He says, in this chapter, you're asked to design a unique ID generator in distributed systems. Your first thought might be to use a primary key with the auto increment attribute in a traditional database. However, auto increment does not work in a distributed environment because a single database server is not large enough, and generating unique IDs across multiple databases with minimal delay is challenging. So then he gives the kind of this back and forth between the candidate and the interviewer. Like, these are the types of questions you might want to ask. So, candidate, what are the characteristics of unique IDs? Interviewer, IDs must be unique and sortable. For each new record, does ID increment by 1? The ID increments by time, but not necessarily only increments by 1. IDs created in the evening are larger than those created in the morning on the same day. Do IDs only contain numerical values? Yes, that's correct. What is the ID length requirement? IDs should fit into 64-bit. What is the scale of the system? The system should be able to generate 10,000 IDs per second. So these are just some of the example question, that you could ask. But there's really, really valuable stuff in here. In particular, this chapter, because you might read this and like my first thought when it was like design a unique ID generator, I'm like, yeah, it's a UUID. Like that's all you need to do. But then there are,
Yep. No, there's
yeah, he says like, well, the requirement is 64-bit. UUID is 128-bit.
Right.
The requirement is that IDs generated in the morning are, that you can sort them, right? You can't sort UUIDs by time, or even if you were to do a timestamp and then slap a UUID onto it, right? Now you're already 128 bits is already too large, but now you're larger than that. So yeah, just lots of really great clarifying questions in this particular example, and the type of questions you should be asking.
And I'll tell you, I personally got obsessed with this for a little while. So I was like, oh yeah, I would have done, because there's several there's three I could just off the top of my head I can think of that are common. He mentions one of them in this book. So there's like Snowflake ID, which came out of Twitter. But there's also ULID and XID. And these are interesting because like they're sortable, and a lot of them have the kind of cool features, right? You can namespace by server. So if you have unique identifiers for your servers, you get a unique namespace. They're sortable over time because they typically have some sub chunk of sortable timepiece, and they typically have some sort of like entropy guarantee, so that if you have concurrent processes on the same server that happen to have similar timestamps, you can still, like if there's a race on your smallest increment of time, right? Because at some point you have to decide what's the granularity. Is it nanoseconds? Is it, whatever? You can still have a little bit of entropy, which is like some random number generator that kind of appends to the end. It's a juicy problem, and there's a coordination problem to it. You always try to figure out, and like this is where like this section of the book explores all those things, and these are fun. Like, hopefully you find that fun. Otherwise, you might be in the wrong field. But
why are you listening to this podcast?
Yeah, exactly. So like, I looked at it, I'm like, oh, this is awesome. I like this. But it's true. If you're having to do one for yourself and you're not just like regurgitating Snowflake or XID or ULID, or they give you something that's like inherently a variation on those, just to see if you have enough under familiarity, but you can, because a lot of these too you're like, what are the pitfalls? What are the trade-offs, right? Like we always want to hear these things too in the interviews.
Let's talk a bit about back of the envelope estimation.
Yeah, I love
that. This is good stuff, right? And I think this is something I'd like to be getting better at. And I think this is something people miss in system design interviews. So what we're talking about by back of the envelope estimation. You can't know what system you need to design without knowing the amount of stuff it needs to do, right? Designing a system, a web server that handles 10 requests a day is trivial. Throw that on your Raspberry Pi and plug it into your wall, right? Designing something that handles 10 million requests a day is way harder. Same when we're talking about databases, right? If you're like me and you're really concerned about scalability, you need to, NoSQL can be a really powerful tool, but it also just kind of depends on how big your data is. I mean, if you have a billion records, but each one is 1 byte long, that's very different from having a billion records where each one is 20 megabytes long, right? And I think like reading that's something I want to be better at. Like when we talk about like, okay, so I think the System 9 interview I whiffed on was about it was about designing like a hotel system, like just for managing reservations. I wish I'd asked that. Like, how much data is in a reservation? What's and then how many reservations do we expect to have? How long do we need to retain the data?
Right. How bursty is the data? That's one that'll catch you up, right? Even if you say 10 million in a day, so like quick back of the envelope, right? If I want to figure out requests per second, I would do divided by 24, divided by 60, divided by 60, right? That gets me down to requests per second. That actually comes out to like 115 requests per second, which is non-trivial. It's a decent amount of requests per second. But very rarely is that just like a consistent data stream of 150 requests per second. You might have a burst of 600 requests per second for some period of time and then down to 10 requests per second. And that changes your design, right?
Mm-hmm.
You need to understand what your upper bound is. You need to, is there scaling stuff that has to go with this? Is there, if it's bursty, this also might trigger, maybe we can use a queuing system because that's a really great way of evening out bursty traffic, and lots of great stuff that comes out of it.
Yeah. What about you, Nathan? Any thoughts on back of the envelope math? Any of the?
I love it.
Yeah.
This is one where I think we all can probably do better. Like, I think what ends up happening is if it's in a domain you've done a lot of work in, you get pretty good at doing back of the envelope with requests per second or something, right? But there was like a couple of other areas that are like, you need to be really familiar with this. I don't have this memorized. I do understand that, like, if I can do it in L1 cache versus having it go to memory references to going onto disk, right? Like that's the order of like speed. Can I keep it in a heaps versus stacks? There's all these like kind of cool basic algorithm things. I would probably, if I was going to go to like a Fang interview, I'd probably memorize these ballpark time, because they have a whole table here. It's like 0.5 nanoseconds is an L1 cache reference. If you want to do something that's pretty impressive for back of the envelope, just memorize these times that go to like disk seek and things like that, and just tell them like, hey, I'm gonna say that disk seek takes 10 milliseconds, right? It doesn't matter, hardware changes, NVMe versus block storage on network storage or whatever. There's going to make big changes on that. But if you can get them to agree to the assumptions that you're making, you're like, I'm going to do a back of the envelope calculation. This is what I think the unit is per read. This is what I think that, and they can agree with you, or they go, oh no, I think that's too slow, or that's too fast, or you can assume that whatever. You'll just come off looking better. I think another area that they talked about was SLAs, like understanding both. Again, they have a great one. It's like, 99% availability means you can have 15 minutes of downtime a day, right? And that's one of those, like, I just have memorized because I was SRE for a long time. And so when I'm negotiating 3 nines, right, 99.9, that's a minute and 44 seconds. I don't have that perfectly memorized. I knew it was under 2 minutes, but that's 2 minutes of downtime a day. If you ask for 4 nines, that's 8.6 seconds per day, right? Well, that's a much different conversation of like what's acceptable downtime. Going from 8 seconds and that's a violation to a minute and a half, you got a lot more wiggle room. You can do a lot more. It's a lot more forgiving to get a minute and a half versus 8 or 9 seconds.
Well, and memorizing this sort of stuff and being able to do these back of the envelope calculations, it's all about what sets you apart from your the other candidates you're potentially competing against. I've made a promise to myself that the next time the market is hot again, I'm gonna make hay while the sun is shining. Just because it's the market's is a little frosty right now. I don't think it's as doom and gloom as people say. Like I had to get a job a year ago. I had to switch jobs and I got plenty of interview offers, but it's true that expectations for interviewers are a lot higher than they were in the past. I just think it's funny, like Amazon is kind of famous for like they've got the hiring bar and the hiring bar is always moving up. It's not always moving up. Amazon is not immune to the laws of supply and demand. I think a lot of companies are looking for higher caliber talent these days just because they're able to be pickier. This is one of the ways to signal that you're higher caliber talent.
And I will say this really does squeeze folks that are earlier in their career, right? If you're lucky enough to have got some experience under your belt, especially if it's working on problems that are interesting to other companies, you are marketable even in bad environments. If you are a recent college graduate with no internships and you've never worked in a startup or enterprise type stuff before, well, that company knows it's going to be, there's a lot of training that they're going to have to do, and there's a lot of stuff that you just never have solved these types of problems. The best way to maximize this is to actually build personal projects related to these systems design interviews and just get good at doing these. You can't overcome it. We just hired a recent college graduate, actually mathematics undergrad, but who is just a great programmer and helped solve the types of problems that we're looking at. It's not common. A lot of times we are hiring folks that are not junior dev, but when we identify unique talent, we'll grab it, right? Like it was one of those where we're like, we're going to learn something from this guy while he's learning a lot from us.
Yeah.
Like, I was never one of those people. So, I look at this and I'm like, this is a really cool situation to be in, but yeah.
Well, and system design, building these sorts of things on your own, especially if you're a new grad or even if you're, not, like you said, Nathan, it's a great way to set yourself apart. I love, there's no doing well in job interviews is kind of similar to like being healthy, and that there's not a lot of secrets to it, right? There's no tricks. It's like, I know what I need to do to be healthy. We all know what we need to do. You got to exercise. You got to watch what you eat. You got to, there's not a lot of tricks to it, right? It's just hard. It's hard to do those things.
I think it's the same thing of like, well, if you purport to be, nutritionist level knowledge, then show me. Like, give me a meal plan for the day. What are the considerations? Like, I'm trying to get stronger. What's the protein intake I have if I'm this height and this much weight? Like, that's a technical interview for a nutritionist, right? Like that would verify whether they actually know what they're talking about. Versus somebody like me, I'm like, this is what I've been doing.
Exactly right. I lost 60 pounds eating Taco Bell every day. That was my.
That's amazing. I did not. I did not do that.
I don't recommend it. It's good if you were literally only concerned about losing weight, and if you're concerned about like muscle mass or any other measure of health, it's you'll just be sickly and frail. But in terms of like kind of the same thing, like getting your resume picked up. Like there's no secrets. Like you need to set yourself apart. You need to look different from the other candidates, right? As you get more work experience, it's going to come as a result of the places you've worked at and the things you've worked at those places. But when you're a new grad, like I'm always telling, especially people looking at internships, like, you know what I'd love to see on a resume? I'd love to see anyone who did a personal project that used AWS in a meaningful capacity.
Yep.
Right.
Yep.
Like anyone who's built out even the semblance of a system. I'm always trying to sell people on if it were me and I were trying to get something picked up, I would do like one of those text-based dungeon games, like you're given a scenario and then you're given like 4 options or whatever and you just choose one. Because what I love about that project is it can scale up really well. Like it can start just running in your terminal, right? But then you could restructure it all as a REST API. And I will say, ever since we read hypermedia systems, I'm like, should I call it a REST API or is it a JSON data API? I'm going to call it a REST API. Sorry,
Carson will get furious.
Yeah. It's like then it can be a REST API, and then after it's a REST API, okay, well, can you put it up in the cloud? Can you host it in AWS? Can you instead of communicating with it via the command line, can you make a React application that displays the text, right? Can you host that React application in AWS? Like there's a lot of incremental improvement to be made there. And if I saw a candidate with that on their resume and they list all the different AWS services they use and how they got it up and running, and especially if there's a URL that I can click on and go play the game, like that would really make a resume stand out to me.
Yeah, and I will say it would be really valuable to read this book and go through these. And I mean, you could just memorize the stuff that's in there and you'll probably do pretty okay. There's nothing that replaces building it yourself.
Oh yeah.
Right?
Oh yeah.
So like, let's say you really liked the section on design a key value store and it talks about 3 or 4 different approaches. If you really want to ace that interview and you've never built something like that or been on a team that built something like that, this is a perfect example of like, go tinker with it. Go build the thing that's in there. You're going to find surprising things. You might even find a bug in the book, right? You might find that they skipped a step or didn't talk about something that would look really good on a technical interview that you understood. Oh yeah, you have to be careful with this key value store to check for this or that, right? Like, and do these kind of interesting things. I like that the projects get more practical as they go on, right? Like I actually loved chapter 8 and 9. Chapter 8 was a design a URL shortener.
That's one of my favorites.
That was fun because again, it wasn't incredibly complex. It was really a testament on getting clarity on your design constraints. Because URL shortener is a pattern that people are familiar with, right? You take a URL, any arbitrary length URL, and you give back some consistent thing. They of course gave a bunch of requirements like, oh, the hash can't be longer than this, or do a bunch of these other little pieces, and that's cool. It's like a juicy little problem that you could, and I think in that one they're expecting you build a little REST endpoint, handle duplicates this way. What happens if it's missing values? What happens if, and there's lots of approaches to this. Do you hash and include all of the URL parameters, or do you ignore URL parameters, right? Those would be like, because a lot of URLs have like affiliate marketing tracking links and stuff like this. Well, is that a unique hash? Or in your system, do you really just care about, having that one time? Those are design constraints and things you have to think about, right?
Well, and like, chapter 9, all about designing a web crawler. You had mentioned that you had designed a web crawler, right?
Yeah, I'd actually built one in real life. I had no idea what I was doing. I was actually learning. I was learning Go. Like I'd taken Go from like a hobby tool to something that I was serious about writing Go for. You would like this. I actually used lambdas.
There we go.
And a queuing system, and it was a distributed web crawler where we had a whole locking system that was actually done in Redis. It was really kind of interesting because the lambdas could call themselves. It was a recursive like lambda web crawler that would run massively parallel. But we also needed to be polite. We needed to honor robots.txt. There's like all these like rules of ways that you do crawling and scraping. And it ran for years. Like I think that project ran for like 4 or 5 years. It was like used by this fintech company that I was just making this thing in my spare time outside of my like DevOps role. It ended up becoming this like my most mature, you know, software project that had it was kind of cool. It was like a distributed crawler thing, and it was like fun to talk about. I brought it up in interviews that I did in the future, and I was able to like talk about the caveats. And again, I think that a lot of this what web crawler chapter would have been lost on me unless I'd actually built one myself. And I'm like, web crawlers are hard. They really are. Because you can waste a lot of resources easily. You can crawl in really dumb ways. It's gotten even harder because SPAs are so big now, right?
Mm-hmm.
Like now your crawler basically has to have a whole browser rendering engine in the crawler so that you can actually like extract
That's crazy.
links, you know? So it gets, it's wild. It's not easy stuff.
If only we were all using HTMX,
right?
Then our web crawling would be easier.
And I will say, like, if you're doing things like crawling news sites and stuff, that actually has gotten easier. Their news sites have gotten really good at server-side rendering a lot of the core content, maybe a lot of the other nuanced things, but getting the core of it, because some sites want to be web crawled, and server-side rendering is really nice for web crawlers. You lose a lot of web crawler capability if you do it, you know, SPA style. I think they actually talked about this before, that a whole chunk of the internet, especially in the early 2010s, was like lost because crawlers didn't know how to crawl SPAs, right? And so, you know, things like the Internet Archive and stuff like this are unique in that they do really cool crawling stuff. But a lot of other kind of commercial data miners and stuff like just didn't adapt for a while. So yeah.
Well, I think that about takes us through the first half of the book. Really interesting book. We're excited to read the next half. Like we said, we're going to take a quick break next week just to cover some interesting essays. I have an on-site and a midterm, which are consuming way too much of my time. So we're human too. We gotta manage the hours in our day. But as far as the first half of this book, Nathan, I mean, what are you going to do differently because you read this book?
So I'm going to read my answer, but I think your answer is better. Mine is that I said not much, that I'm actually like, this is pretty core to what I'm doing, especially as a software architect. I'm not actively interviewing. That's not like something interesting to me right now. But these are the kind of tools and resources that I actually use day to day, thinking about weird stuff we haven't built yet. So this is just a fun book. But I don't have any like, oh, I'm going to do something differently from this.
Well, I just want to be better at back of the envelope estimation, either when I do it, just being more thorough, but also like just thinking about it more in general. Like our project at work, we recently we're trying to integrate more with kind of like the core company monolith. And so, that changes, that puts a lot more traffic on our service, and we need to be more reliable because of it. I don't know if anyone asked, like, how much more traffic can we expect to get from this? How much traffic are we getting currently? Can we handle that, that increase? And even if like it turns out to be totally arbitrary, like we could handle 10 million requests per day, and we're currently doing 500,000, and the core product's going to add another million, right? And we're just not even close to what we think it is. They're still good questions to ask, because like, I don't even know who I would need to talk to at work on the core side to figure out, how much requests per second we should anticipate. I just like to be better at that sort of stuff. So this book was a good reminder.
I think that was a better answer, and honestly, we all can improve our envelope estimations. I think, maybe I was just feeling a little sassy when I was answering that.
I got this.
But that's true. And I think, there's this kind of cool things I've seen. Folks that I've worked with that used to work at Google and stuff, they a lot of times they'll have service budgets. So you actually have to commit to what your upper bound is. And so you're expected to kind of do these back of the envelope things where you say, hey, look, I can look at the data that's coming into Grafana or whatever, and that's maybe my baseline. But if one of the other services in our multi-service architecture decides to change its behavior because they get a new product release, and all of a sudden my service is now having to double or triple the amount of requests per second, do we give them a budget for how much they're allowed to go before the rate limiter goes off, right? And so these are interesting because that way you actually do have to think about what is unacceptable behavior from another service in our company, and those are healthy. Those are healthy conversations, and back of the envelope calculations will help have a good conversation with that team when they're negotiating those kind of things.
Absolutely. And Nathan, who would you recommend this book to?
Okay, so if you are preparing for a system interview, this is the book for you. I don't know. I think that would be the context upon which I would recommend this book. It's a great book, but with a very specific purpose.
Mm-hmm. I think so. I think if you're a junior engineer, I've talked about this at the beginning of my career, kind of wondering like, wait a minute. So I write the code, I run it locally, I merge it into GitHub. What happens after that, right? This is a good book that can kind of peel back some of those layers and give you an example of maybe the larger systems beside what you are immediately interacting with. But I say the same, like if you got system design interviews coming up, like this is the book to read. Alex has done an absolutely fantastic job with it. And highly recommend for anyone who's got system interviews coming up.
If you're mildly just curious how things work, and you should be, that's a great place to be. Byte Byte Go is phenomenal.
Yeah.
Not only do they have a huge archive of stuff that you can read, but it just new things come up, and he's really good about staying on top of like emerging patterns. If you want to, Byte Byte Go is a good complement to Book Overflow in the sense that, you know, if you're trying to expand your horizons, understand concepts, and develop your career, I would absolutely put this in like the, you know, top 5 newsletters you should be paying attention to.
Absolutely. Well, thanks everyone for tuning in. We'll be back next week with some essays, and then the week after that, we'll be back with the second half of this book. You can find us on Twitter at Book Overflow Pod. You can contact us at contact@bookoverflow.io. You can go to bookoverflow.io to find our reading schedule if you want to keep up with us. And you can also find me on Twitter at Carter Morgan, and Nathan's work with Functionally Imperative at functionallyimperative.com. Thanks for tuning in, everyone. We will see you around.
See ya.